Hi, the aim of today's video is to help you start debugging your DAISY projects with visualGDB. The first thing you need to do is to clone the DAISY examples repository from GitHub and then to update the submodules, which are the two libraries the project needs to build. As of right now, the process required to debug or to set up the visualGDB project section is kind of broken, so there's a little bit of tweaking and work we're going to have to do to get these to work. Currently, my fork sedur code of the repositories for DAISY examples, libdaisy and DAISY SP will be needed in order to get these projects running for you. The first thing we're going to do is to run an example of setting up the visualGDB debug project and breaking in. We're going to do that on the DAISY pod. In order to do this, run the Python script helper.py with the update instruction, and we are going to update pod-encoder. That is our target. We're going to need to include an extra flag, which is to include vgdb. And we will get a bunch of extra gubbins set up. If we open this in the Explorer, then we will be able to pod encoder run the solution. Now notice in this particular project we have a main.cpp as opposed to an encoder.cpp, and that will be important in a moment. Let's open up the solution in Visual Studio. Now, once the solution has loaded, you'll notice that we have some errors because the IntelliSense might not have loaded because the project appears unavailable. This is not entirely the case. Let's sort this out. The first thing we need to do is to update the project references. Go to the project name, encoder, references, right click, add reference, and we're going to select the two libraries again. We will now delete the old references, and that part of the process is complete. The next thing we need to do is go down to the device-specific startup files, and you'll notice that this wants to resolve to dgit daisy examples pod libdaisy core da. Of course, this isn't accurate because this is suggesting that libdaisy is a child of pod, which is not true. Perhaps the scripts are assuming that we're not going to live in DAISY examples, but for the minute the example does live in DAISY examples. So we need to add an extra step back up the path to correct the path so it can be resolved to the correct position. The next thing we're going to have to do in this particular case is to change encoder.cpp to be main with a lowercase m.cpp. And notice that it now resolves to examples pod encoder main.cpp. We still need one ... to get us up a level to the correct place because the solution is currently living in the VS folder. The next thing we need to do is to change the vgdb project properties to reflect these path differences. Dash in the linker descript file moves us up a level. We now need to do the same for all of the child folders. And finally, we need to add two new dependencies which aren't included in the current GDB project properties. We need to add libdaisy-source-per, and then we need to add libdaisy navigate through the folder list. We need to add libdaisy middleware's third-party fatfs source. Apply. Looks good. Okay. Now hopefully this will allow us to build our project. As you might be able to tell, I have already built this project. Here we are, so I will rebuild it. And there we go. Now, assuming that you have some hardware set up with an ST link, as I've got it, all you need to do is to run the visualGDB debugger. The debug perspective will be loaded, the flash will be loaded, and the project will break in. The next easiest thing for you to do is to go back into the project, set a breakpoint at the start, because it has actually halted at the first instruction in main. But visualGDB hasn't quite picked up the right location for the hardware, so the best thing to do is just hit a breakpoint, restart the process, and here we are in main, and we can see in our autos we have the hardware init call and main, and we can just step over the init of hardware, lead cell, ink, start initting colors, continue, and my daisy looks nice and red. Okay, this is all well and good, and we start the audio callback, but what happens if we want to make our own project? Well, the process is relatively similar. Now, instead, when we call our Python script, we are going to create, and we are going to create our project in an appropriate location. Now, I have a subfolder called My Projects, and we are going to create a new project called Another Pod Example. And you'll see we've got a UTF-8 decode error, which perhaps is a hint of why the Python script for helper isn't currently working correctly. But anyway, we can kind of disregard this because the project's already created. It's kind of complaining now if we try to overwrite it. So let's go open our folder, Explorer again, My Projects, Another Pod Example, and open the solution. From now on, the process is much the same as it was with updating an old project. First thing we need to do is to change the project references. Reference do and remove the old project references. The next thing we need to do is to go into the sources, making sure that we can find our source file, and then move the relative location of startup stm32h750xx.c up one level. Now we need to go into the visualGDB project, and we need to update the location of the linker script and the location of the source files. You'll see that there is an extra hash once again here because Python is failing to appropriately escape, but Windows shouldn't be bothered. Dash. Okay, and then let's add our two extra new sources, because visualGDB isn't used all that often, I don't understand, by the developers anymore. So they've kind of fallen by the wayside a little bit. libdaisy, middlewares, third party, fatfs, source. Apply. Everything looks sensible. Debug. Apply. Okay. Now we can rebuild our project. After a little whir of the fans, the project has completed building and is using 84 kilobytes of the total 128 kilobytes available. not ideal. We can still also throw in a breakpoint at the start of main, enable the visualGDB debugger, and after a moment break into our project. Run our init, set the 4 sample block size, set the 48 kHz sample rate, start the audio callback, and enter the while one loop. Perfect. So that's the first kind of basic step in order to get a project set up. Now there is one other thing that can be a bit of a pain that we need to figure out, and that's being able to ignore clang. Damn you. It's to be able to print stuff to the console if we're doing print debugging, which is my least favorite kind of debugging. You know, we have access to registers in debug in this hardware, but sometimes needs must. So let's print a message which is hello world, and we'll put in an integer r-n to end our lines, and we are going to put in the integer a step. We are going to create our int32 step. We are going to wrap step at 127. 32t wrap equals 127. Of course, you could just do 128 minus 1 or 1 shifted left a bunch of times, but here we are. So we will step and equals wrap. We'll step plus plus, and we will hardware dot sleep wait delay milliseconds 1000. Okay, let's build this, run it. Continue. And in theory, we should be getting a load of noise out, but we see nothing. In order to be able to use printfs while debugging, we are going to need to implement semi-hosting. Now, in order to get semi-hosting working, you need to go into your visualGDB project properties. You need to go to the embedded project, hit change settings, and go down to implementations for SBRK, support semi-hosting. Okay. Rebuild. Run. Have the visualGDB output window open. We will halt, we will continue, and we will get a very slow printout. Now, there is a faster semi-hosting library, but I've not figured out how to get it working in this guise of the DAISY projects. In order to add it, however, you've got to go down to the embedded frameworks and install it as an embedded framework, which you can download as part of visualGDB. Thanks.